Hi, welcome to the Unit 1.1 notes. Just so you know, this video will start with a presentation overview before we get into the notes. I'll make it clear when you need to take out your notebook and start copying notes down. So, as you know, Unit 1 is about scientific skills, and we discussed some of this in class that, chemistry is the study of matter, and the way scientists study matter is by observing changes and taking measurements. Now, the main purpose of this unit, just to summarize really quickly, is that we're going to practice the skills that scientists use. So for this first video, we're focusing on measurements, and we're going to look at what, the right equipment to use, and also how to take measurements both accurately and precisely. So we'll start with right equipment. There's only two pieces of equipment that we're going to look at here in terms of taking measurements. The first one is an electronic balance, and it's used to record mass. And mass measures just the amount of a substance. Common units are grams, kilograms, and pounds. The next piece of equipment is a graduated cylinder, and you actually used that in the last mini lab, and it's used to measure volume, which is the space occupied by a substance. And its units are milliliters, liters, and centimeters cubed. Okay, so now we're going to go into choosing the right equipment. We just looked at the electronic balance and graduated cylinder. Sometimes in the lab, there are pieces of equipment that look similar to the electronic balance and the graduated cylinder. So we're going to go through some key features to highlight the differences, and so you know which one is the right equipment. Let's start off by looking at the electronic balance versus the hot plate. They look very similar. They have a similar shape. They both have usually some sort of digital display in the front and an electric plug. So how can you tell the difference? Why don't you take a moment and see if you can tell the difference between the hot plate and the electronic balance. And when you press play again, we'll go through some key features. All right, so you notice with the electronic balance that it has buttons because it's a digital device, and it usually has a round top, which is used to place the object or the container the object is in to weigh it. The hot plate, on the other hand, instead of having buttons, it has these dials. So you can turn up the heat or you turn it down, and it usually has a square top, a rather large square top, which is used to heat up substances. Now we're going to talk about the graduated cylinder. A common piece of lab equipment that gets confused with the graduated cylinder is the beaker. So what are the differences? You'll notice that the graduated cylinder is taller and the beaker is sort of shorter and it has fewer lines. And the reason for that is that a beaker, although it has these volume markings, so it can be a bit confusing, it has these volume markings, but you don't really use a beaker to measure volume if you need accurate volume. So, for example, if you needed roughly 400 milliliters of water and you really didn't care if you had 350 or 450, it really didn't matter, but it was like roughly 400, then you could use a beaker. But let's say a chemical reaction, needed exactly 4 milliliters of water, then you would want to use a graduated cylinder. So, it's super important to know that for accurate and precise volumes, you use this graduated cylinder. And if you don't care about the volume, you could use a beaker. But typically we use beakers to store and hold things. All right, now that we looked at how to tell the differences between the equipment we want to use and other equipment that we'll find in the lab, let's talk about how do we take measurements both accurately and precisely. So accurate means that the measurement is close to the true value, and precisely means that you're doing it with units, you're showing the units, and you're estimating the last digit. Okay, so looking at the electronic balance, we're going to first talk about how to utilize each piece of equipment correctly. The main thing for the electronic balance has these three pieces that you should really pay attention to. One, it has a cover to protect it, so before you weigh anything, you have to open up that cover. It also has an on and off button. If you're going to use the balance and you see that the display is not lit up like it is here, then you hit the on button. And finally, it has a zero or tear button. Sorry about that. So, and we utilize this button when we want to tear off or zero out the weight of a container. So like, let's say for example here, take this container. Let's say someone wanted to measure salt, and you can't put salt directly on the balance, but you can use this little weigh boat container to put the salt in. Well, when you go to measure the salt, do you want the weight of the container as well? No. So what you can do instead is after you take your empty container, you weigh it, you put it on the scale, you weigh it, and then this is the mass of the container, 2.87 grams. And then you can have the scale cancel that weight out by hitting the zero. Once it hits zero, that means that the weight of the scale with the container on it is zero. So anything you add into the container, that will be the weight of the substance you've added to the container. It will no longer be the weight of the container and the substance. All right, before we get into the graduated cylinder, I want us to look at how to use a ruler correctly. One, because you could use a ruler in the lab to measure something like volume as well. But two, because some of the skills that you use in using a ruler, you also use for a graduated cylinder. So let's start off by saying that when you're using a ruler, make sure you line it up, like the object up to zero. So we're weighing, if we wanted to measure the length of this pen here, we would line that up to the tip up to zero. Then we want to find where the other end of the object lies, and here this is where it's showing on this ruler. So we have it all lined up, and notice that this is a centimeter ruler with millimeter markings. Now, which of these measurements would be would you report as correct? Take a moment to take a look at these measurements, see what the differences are, and when you press play again, we'll talk about it. Okay, so the one that's correct is the 14.0 centimeters. All of these are accurate, but however, this one is also precise. Why is that? It's because we estimated the last digit. What do I mean by that? When you're looking at an object, like in this case, the pen, I notice at the end of the pen ends at the 14 centimeter mark. But how do I know for sure? Like I'm really just kind of estimating because my eyes aren't perfect. So maybe the length of this pen is actually 13.9999 centimeter. Maybe it's 14.001 centimeter. I don't know for sure. So what I'm telling the reader is that this last digit here is uncertain. It's certain that it's at the 14 mark, but that last part there, I mean, maybe it's a little bit less, maybe it's a little bit more, is the uncertain part. And so it's super important that we always estimate that last digit, even if it's zero. Let's look at another example here. We have a rectangle, and we're going to do the same. We lined it up to zero, and in this case, the rectangle ends at this marking here. So take a moment to see if you can read where that marking is. All right, it's between, so this is 5.5, so it's between 5.6 and 5.7. So which one of these would be correct? Great, it's the 5.67. Why is that correct? So you notice the first one, there's no estimated last digit, so that one's completely wrong. And the second one, the reason why it's wrong is that this marking, this rectangle is between the 5.6 and the 5.7, but it's slightly closer to the 5.7. And in my mind, that looks like at the 0.67 mark. So I've estimated that there. Maybe you estimated it should be 0.68, or maybe you have estimated it should be 0.65. So that's why this last digit here is important, because it can vary from person to person, but it shows that this is where the uncertainty lies. So someone knows that it's about 5.67. All right, some key points is make sure you line the object up to zero. Determine the scale of the ruler, like we saw with a centimeter with millimeter markings. Estimate that last digit, and don't forget units. The same skills here we use in a graduated cylinder, but there's only one slight difference. In a graduated cylinder, we have this, the liquid will oftentimes curve down or sometimes upward, but this curvature is called the meniscus. And when we read the graduated cylinder, we always have to read the bottom of the meniscus, the very bottom, even when there are two, it looks like sort of like two concave markings there, you have to read the very bottom. The other thing is too with a graduated cylinder, you have to line your eye up to that bottom of the meniscus. So in the lab, the sort of things that I'll see when I know you're lining your body up to your eye up to the bottom of the meniscus is I'll see you will bend down to make sure that your eye is lined up properly. All right, so once you've lined yourself up, you're going to read the bottom of the meniscus, and then just like with the ruler, you determine the scale. So for this example, over here, we see that the millimeter markings go from 10 to 20. So that means that in between each one, this is 11, 12, 13, etc. So once I know the scale, I can read the bottom of the meniscus, and I see that it's close to the 14, but it looks like it's slightly under. So I'm going to say that that's 13.9 because it's just slightly under the 14 millimeter mark there. So I've estimated that last digit there, the 0.9. And the last thing, of course, don't forget the units. That's super important so people know the accurate reading. Now we're going to go into notes. So let's take a moment to pause the video and get your notebook. You're going to skip the first 2 whole pages of your notebook for table of contents and get ready for the notes. Okay, so here are the notes. You're going to copy these down into your notebook after you skipped your first 2 pages for table of contents. We start here by talking about lab equipment, what to use and how to, and taking precise measurements. For the maths, we're going to use an electronic balance. And I want you to draw the images for the steps, and underneath each step, leave some room for details on each step. Take a moment to copy this down, and when you press play again, each step will be revealed. So here's the notes for step 1, step 2, and step 3. So step 1, you want to turn the balance on, wait for it to clear, and then hit 0 if the balance doesn't read 0. For step 2, you want to place the container on that you will use to hold the object or the substance, and then wait for the balance to settle because sometimes the numbers will keep moving. Once it's settled, you can hit 0 to tare, meaning that you'll cancel out the weight of the container, or you can record the mass of the container. Once that's done, you can take the container off the scale, place the object in the container. The main thing is don't put the object in the container while the container is still on top of the scale. Take it off first. Weigh the object in the container and record the mass. If you hit 0 in step 2, sorry about that, then you recorded, then what you're weighing there is the mass of the object. If you did not hit 0 in step 2, then this last part which got cut off, if you did not, you have to subtract the mass. So add on, subtract the mass there. Okay, we're going to take notes for volume now, so take a moment to copy these notes down. And as you're copying, I'll read out the steps. The main thing is volume is equal to length times width times height, so you'll use a ruler to measure those, and then you're going to multiply all 3 measurements to calculate the volume. The other way, besides a ruler, is a graduated cylinder. So once you get the information for 2A, which is ruler, down, we're going to go into a graduated cylinder. A graduated cylinder is also used to measure volume, and as we've said before, you want to line your eye up to the bottom of the meniscus. You're going to find once you find the bottom of the meniscus, you record the volume, and always estimate the last digit. So we have some examples here of where we've estimated the last digit based on the scale of the graduated cylinder. You're going to get these notes down, and after that, you are done. I hope you guys have a quality day. All right, take care. Bye.